Good afternoon, everybody. I hope I will keep you up after lunch. So I'm Massimo De Leoni from the University of Padua. As a joint work with the Steco, a company in Trieste that works on business process simulation. And this paper focuses on process mining. Many of you know, but maybe it's just a small summary is good. We have information systems. You record activities and how the process proceeds over time. So you get these event logs. They are the input for many techniques that are able to extract information about how processes are being executed. And the starting point for any process mining technique is, many of you know, is an event log, which consists of a case identifier, an activity, a type of, whether it's a start or completion of a certain activity, a timestamp here, just a number, and the resource that perform the activities. Each of these is an event, and that's what you start in process mining. And one of the things they can do in process mining is to try to compute how long activities usually take to be carried on. And for example, you can observe here the activity A for the first case started at time 10, concluded at time 12. So you know that it lasted 2 time units. You can do for another activity, for a third activity. And so by just summarizing this, you are able to understand how long activities will take, usually on average in the process. And then when you can compute some nice graphs, and you can show that, I don't know, the distribution of activities, the duration, you can project duration on the model, and you can get a nice insight into the performances of the process. That's very nice. And then you can use this information also to build a simulation model. In the simulation model, what you do is that you want to, it's a versatile way to perform a process. You can then simulate the process. You can do analysis, change scenarios, and so on, and try different alternatives, what is called what-if analysis. And this way, you will be able to perform a process. Of course, when you do this, you need to specify the process model. You also need to characterize the activity durations, the distribution, the follow, and so on and so forth. A normal distribution, for example, for this activity, exponential for another, so on and so forth. All of this can be done if you have a start and completion of each activities. Then you can compute the statistics, you can compute distribution, activity duration, and so on and so forth. So the starting point here is that you need this information. Unfortunately, it's often the case that information systems do not store when activities were started. So you don't know, the system doesn't store this information. As a result, the event log misses these events, here pictured as black lines. So you don't know when activities start. And this way, you cannot compute all the nice stuff I talked to you about, activity duration, business process simulation model, so on. That's not possible. So what you do, usually, you have to now start guessing what this timestamp were. And most of the approaches say that the timestamp of the starting event is equal to the timestamp of the last event that preceded in the same case. So you would guess, for example, that since the first activity of the case started finished at time 12, the next activity will start at time 12. So you do this estimation, but this estimation is not often correct, because in reality, it's not sure that the resource will be immediately available for doing so. You also don't consider that people are not robots. People have fatigue effects. Once in a while, they have to have a break when they perform their activities. And this somehow, they have a break, or they receive a call. There are other stuff they do that is not recorded in the event log. So just assuming that you start as soon as you can is not realistic in practice. In practice, there will be some delays, some waiting time due to resource availability, other stuff that is not recorded in the log. So something like this that's often done in practice, in many case studies, is often very wrong. The reality is that, let's see, suppose the activity finishes at this timestamp. So what you can say is that either, when can this start? When the previous one completed, or if you have a resource information, you can say, well, this activity finished It was performed by resource B. And when did it start? As soon as resource B was available. That's, again, an estimation, is a mistake, because people don't start immediately. They have other stuff to do. They call, they go to the bathroom, and so on. So the reality is that the timestamp is not exactly this when the new activity started, but something in between. So now the problem here is to guess what is the value in between. And for doing this, what we do in our approach is that we say the timestamp when the activity started is sometime between the time when the activity finished and the earliest time in which it could start. So the earliest time would be this. The time when you finish was this. And you have this parameter alpha that varies between 0 and 1 and allow you to find some time in between. There should be an alpha for each possible activity execution. Well, that's true, but this is difficult. Imagine you have an event log with millions of activities, so millions of events. You cannot assume that you have million times a different alpha. It's not tractable in practice. So we approximate saying there will be the same alpha for all the activities of the same time. And so you say that the timestamp will be between the earliest possible time and the time when it completed according to this formula. Now the question is that, okay, there is an alpha for each activity. Now we want to estimate what this alpha is going to be. So you have an alpha for activity A1 until an alpha for activity AN. And you need to find these vectors of alpha, and you have to find the best that characterize the start timestamp. If you find the right alpha, you will find the right start timestamp, and then you can really have the right values. So the problem here is to estimate this alpha. So how do we, suppose that we have one configuration of alpha, and we want to know how good is this configuration. What do we do in our work is that we start from event log. They don't have, of course, the start time, the start events. We use our formula with the right alpha that you use for the configuration. And then we got this extended event log, in which we guess some real start timestamps. Okay? Of course, we don't know if this how good is this configuration, and so the start that are added. So what we do here is that we build a simulation model that are basically from the event logs using standard techniques. You can build a simulation model. Then we simulate this model, and we get a simulated event log. Now the question is that we want to compare this extended event log and this simulated event log and see how close they are. Now we will go through step by step all these phases. So building a simulation model, this is already, there has been a tutorial today, there has been also a presentation yesterday by people from the Marlon Dumas team. Now it's becoming standard. You discover a process model, for example, a BPM model, and then you extend this model with all the information that characterize how the process statistically is being executed. So you discover roles, data decision perspective, we discover branch probabilities, working hours, distribution of the inter-arrival rate of the cases, because you want to know how often the process is being fed with new cases. And then, of course, you need to know the duration of the activities. So that's what we do as the next step. Then we have this model, and we simulate it. And we know that the business simulation model is a stochastic generative model. What they mean is that a stochastic generative model is something that can produce process executions. So you can simulate this model multiple times. You get an event log. This event log is the simulated event log. And we simulate this event log so that we generate as many traces as the original event log from which we had at the beginning. So we have this extended simulated event logs, and they are of the same size, so the same number of traces. Last step now is we compare these models, but we don't compare as many other approaches do, because here we aim at certain information about process resource information, let's say. So we compute the distributions of trace duration of the trace duration of the real event log and the trace durations of the simulated event log. So we know what is the distribution of the trace durations. Then we compute the waiting times in the simulated and the real event logs for each activity A1, AN in the model. So we know the distribution of trace durations. We know the distribution of waiting times for each activity present in the process. And now we want to compute some difference. We also compute, so both for the real event logs and the simulated event logs, we compute these waiting times. So how close are now these models? We use this formula. Basically here it says, here this computes the difference of trace duration distributions. And then we compute the difference for each activity in my process, the difference in the waiting time distribution. So these accounts, we want to consider how traces are different in duration between the real and the simulated event log. These accounts how different is the waiting times for the different activity in my logs. And this is our error. So the error is larger if the two event logs are different with respect to this information. Of course, so then we know now that if you have a configuration, we can evaluate this configuration of alpha and get an error. Of course, we don't know which configurations to use. And so here we look through a greedy search. In the search space, the best configuration. So basically, you start looking in the search space of the possible values of this vector, the one that minimizes the error. And here we use a simple approach, but in the future we are aiming at using genetic approaches that can better estimate this alpha. So at the end, now we know what are these alpha. So we can now use the formula we said before, and we know what are the best start timestamps. For the evaluation, we did a case study with a student credential recognition process at the Columbian University. We decided to go for this log because it was one of the few that actually had the start and completion. So we had start and completion. This allowed us to remove the start events and try to rediscover them and see how they are far from the reality. So how good we can estimate this information. In particular, for evaluation, we consider three aspects. The estimation quality with respect to the simulation model. Of course, here, you generate your simulated event log for comparison with the real event log through a model. And the model may change because you can change parameters and so on. How much this affects the quality of the start events that we obtain, and so the activity duration. Then, of course, we compare with naive techniques. At the end, you don't care about start events. You want to use them to do something else, for example, to build a nice simulation model. So now we will also discuss some positive impacts of this start event onto the quality of these start events, how this impacts the quality of the business simulation model. So how we did is that we used inductive miner to build a Petri net. And we translated that to BPMN. So this was the initial backbone of our simulation model. And this inductive miner has a parameter, a noise parameter that varies between 0 and 1, where 0 indicates that all event log behavior is allowed by the model. A value 1 indicates roughly that small amount of behavior is allowed by the model. So varying this parameter, you can vary the simulation models. And so in theory, you should vary the quality of the start events that you derive. In fact, you see that the different models at the end generates start events with a mistake, an error that is not really depending on the quality of the model. So the model is not affecting, that's a good thing, because if it affected a lot, it will be an issue to find the right one. But it's not really affected by this, so basically any of these models were good enough. The second thing is that we want to, of course, compare our approach with naive techniques. We say the naive techniques are, well, you don't take a value in between, you assume that the activity started as soon as possible. And that's exactly the case here. You started as soon as the resource was available. And the other scenario is that if you don't have resource information, as soon as the previous activity was performed. And now you compare with this approach, you see that our approach compared with the naive approaches in which assumes no waiting time, no fatigue, the error in the estimation of the start timestamp is much smaller than the error of the significant difference, both in averages and in the variance. The other is the third approach that we want to discuss is that how this timestamp, the fact that they are getting better, how is this affecting the techniques that will use it? Simulation models require, for example, defining the distribution of activity durations. So if you guess well the starting timestamp, you guess well the distribution of activity durations. And the distribution of activity duration are computed using the event log with start events. So we use the one that we computed with our techniques, and the one computed with naive techniques. And here we show that, for example, that our technique has case durations that are very close to the one of reality. So basically, this is computed using our technique. These two are computed using naive techniques. This is the actual timestamp. Recall that the event log had timestamps of starting, so we are rediscovering. And then you realize that our technique is able to more or less have case durations that are close to the real case durations. And this is indication that our simulation model is very good in mimic the actual start timestamps. To conclude, so the paper tackles the important problem to derive the timestamp of the start activities from event log. We have used them a lot also for improving the business simulation model, but you can use also for projected duration to the model. Also, many discovery algorithms uses this information to discover parallelism. So if you have start timestamp, you can discover parallelism and so on. So it's important to have them as close as possible to reality. And we use a different activity duration configuration. We tested it and simulated to find the most suitable. And to conclude, the results shows clearly tremendous improvement with respect to naive techniques. This is, for us, at the beginning of the research was obvious, because the people are not, the assumption that you start an activity as soon as the previous completes is clearly wrong. People have to have breaks and so on. So indeed, our approach shows improvement with respect to the state of the art. This concludes the talk.
Thank you. Questions? Okay. You make me work a bit. Thanks.
Thanks, Massi. So a question on this choice of alpha, right?
Yeah.
So I completely agree with you by looking at the presentation, right, that having an alpha per event would be completely unmanageable, right? But were you able to understand whether this decision of assigning alpha to activities was good enough for the setting? Because an alternative that at least comes to my mind would be to assign an alpha to a resource, right? There are people, for example, that tend to do things at the earliest convenience or as late as possible, no matter which activity you give them, right? So yeah, this could be an alternative choice, or you could have also combinations thereof, right?
Yeah, so it is not reported in the paper is the results that we have achieved later. And the results shows that indeed it's true, that different execution of the same activities are okay, they have like the same duration. So And it's not necessary to go to event level and to take the specific event, but you can go to activities. Can you ask, the second part of your question was, can I use alpha and make it depend on resource? This I would doubt, because the same resource can perform very different activities. From just checking a document to do some thorough assessment. You cannot use the same alpha in these two cases, I think.
Thanks. The other question, yeah.
Thank you. What is often missing in event logs is actually the waiting time, right? And sometimes one might have a guess what the typical waiting time for a typical activity is, or what the constraints are, more or less. Can you essentially shuffle around the variable and solve the waiting time problem with a similar approach?
So I assume you mean waiting time, you assume really the time from the moment in which the activity was enabled to the moment it was started, right?
Yeah, so it
Because
can be waiting time,
there are
but
two waiting times. The waiting times because you wait for other parallel branches to finish. There is waiting time from the moment in which it's available.
yeah, so waiting times, but also execution times.
Yeah, so that's what we aim at, indeed. If you go back and I take this example, what at the end we do is that we estimate the waiting time in some sense here. So here, the waiting time starts here, when the activity is ready to be performed. So it's enabled, it can be performed. And we need to guess when it really started, so we guess this part in between, which is the waiting time. So the approach is indeed to try to estimate the waiting time.
Okay, thank you.
Any other questions? Yeah.
Thank you. I'm wondering whether, thank you for your talk. I'm wondering whether the simulation model is totally data-driven, or you allow for some expert to inject some knowledge. And in particular, because I believe that in your schema, the simulation model exerts a sort of regularization. Maybe it suffices only to have some information about the form of the distributions. Maybe that can help to regularize what you have discovered from the log, from the original log. So the question is totally data-driven, and there is some choice made by experts about maybe the form of distribution, the distribution, time distribution, and so on?
Okay. So here I simplify the picture. We actually, I lied a bit. We don't discover a new simulation model for each event log, for each configuration. Most of the simulation model is discovered once, and only activity distribution are let's say, changed according to the configuration. So here, for the sake of simplicity, I just say that I do it that way. Now question, should I trust the guys that tell me that the distribution are those, or should I trust more the data? My answer would be that I should not trust the guys too much. The guys can give you feedback on what you find, but I would say that it's better you don't trust them. At least in my case studies, companies always happen that they don't, when you show the data, they don't believe you. They say, no, what you are saying is all bullshit. Oops, I should not say that. It's incorrect, but at the end you show them that it's correct, and it's their perception of the process is wrong. I think data science and general process mining is indeed to try to put subjectivity aside to focus on the data objectivity.
Thank you. Any other questions? Just very a curiosity, Massimiliano, is your tool available? So are your experiments repeatable?
I think now we are, yeah, there was some...
Or is intention just to know the future of it?
It's now, it's with the company, so the company...
In fact, this is why I asked. So in any case, they will they are interested also in some practical and commercial exploitation,
Yeah, there is
probably.
a person from indeed from the company.
Okay, good to know.
And yeah, I think by the way.
We'll speak afterwards, okay. Thank you.
Yes, but yes, they are gonna put in their software. So.
Okay, very good,
So
interesting
that's
to
why
know.
it was not easy to put.
No, but the fact, my question was, is that already the intention that they will put in the software, it's for me very valuable contribution. So the idea is that research is really then applied in real application. It makes me very happy personally. Okay, thank you. I invite the applause and the next speaker.